Does acid rain make new substances? Getting ready. You have learned that the Statue of Liberty turned green because of a chemical reaction. Perhaps you know that people's hair can also turn green. People with blonde hair may have experienced this. When you swim in a pool, a green substance can form on your hair. It shows on blonde hair, but it does not show on dark hair. It does not happen when people swim in lakes, only in pools. Use what you know about statues, roofs, and pennies to make a guess about hair. How do you think the green substance on these other objects could be related to the green substance people get on their hair when they swim in a pool? Copper is involved in several chemical reactions. In class, you completed an investigation in which copper reacted with acetic acid to produce copper acetate. You used a copper square and vinegar. The copper acetate that formed was a new substance. People who wear copper bracelets have probably seen this reaction. When someone wears copper jewelry, the sweat in their skin contains acids that react with the copper. This reaction produces a green substance. The substance is similar to the one on the copper square or a penny, and similar to the one on the Statue of Liberty. Another example of this kind of reaction occurs when people swim in pools. Chlorine and other substances are added to pool water to kill harmful bacteria. Chlorine helps to make pools safe for everyone. If the pipes that lead into the pool are made of copper, a chemical reaction can take place between the chlorine, other substances, and the copper. The reaction produces copper sulfate. Copper sulfate, like copper acetate, is green. People who swim in the pool get copper sulfate on their hair. People with dark hair will not be able to see it, even though it is there. People with light hair, especially blonde hair, can see it. They sometimes say that their hair turns green when they swim in pools. Their hair does not actually turn green, but it gets covered with a green substance. The substance washes away with shampoo. This green substance is a product of a chemical reaction that occurs in the pipes leading to the pool and then ends up on the swimmer's hair. Are all of these green substances the same thing? The green substance on a copper square, a penny, the Statue of Liberty, and the hair appear the same. They are all green. Are they all the same substance? Before you read 3 explanations, look at the following table. Use the information in the table to help you think about whether the products in these reactions are the same substance or different substances. They are all green, but are they all the same substance? Comparison of copper and copper sulfate. What do you think? Are the substances the same? What follows are the 3 explanations that other people have written. They looked at the data table and made a decision about whether they thought that the green substances were the same or different. Then they wrote scientific explanations about their ideas. Read each explanation. In the space that follows each one, write what you could tell about the person who wrote it so that they could improve their explanation. Here are some things to think about. Does the explanation have a clear claim? Is it accurate? Does the explanation use the data from the table as evidence? Does it use the right data? Does it use the data correctly? Does the explanation show good reasoning by stating the scientific principles that help the claim and evidence make sense together? What does each explanation leave out? Explanation 1. These 2 substances are not the same. They are both green and they are both soluble in water. One substance has a melting point of 115 degrees Celsius. It is soluble in alcohol and it has a density of 1.88 cubic grams. The other substance breaks apart at 560 degrees Celsius, is not soluble in alcohol, and it has a density of 3.6 cubic grams. They have different properties. How could this explanation be improved? Explanation 2. The 2 green substances are not the same thing because some of their properties are different and some of them are the same. If they were the same substance, all of their properties would have to be the same. How could this explanation be improved? Explanation 3. The green substances on a copper square, a penny, and on the Statue of Liberty are not the same thing. Although they are both green and they are both soluble in water, they have different melting points, densities, and solubility in alcohol. Substances have properties that are always the same, so the same substance cannot have different properties. These 2 have different properties, so they have to be different substances. How could this explanation be improved? Why can you only make some substances from other substances? You have learned that a pure substance is made of the same atoms or molecules all the way through. Your definition of chemical reaction can now expand because you know more about atoms. Here is a new way of thinking about a chemical reaction. A chemical reaction occurs when substances interact and their atoms combine in new ways to form new substances. The new substances are made up of the same atoms as the old substances, but the atoms are arranged in new ways. Using the cake example to understand atoms. Most of the ingredients in a cake are not pure substances, but the cake example can still be helpful in thinking about chemical reactions of substances. If you put flour, sugar, eggs, and milk in a bowl, you will not end up with orange juice. The atoms in orange juice are not the same molecules as the molecules in flour, sugar, eggs, and milk. You can get pancakes from those ingredients because the molecules in flour, sugar, eggs, and milk can rearrange to make pancakes. When the ingredients are mixed and cooked, something happens. The molecules and the atoms they contain rearrange to form something new. The new arrangement of atoms creates new substances with new properties. When scientists say that a substance has characteristic properties, what they mean is that the molecules that make up the substances give it certain properties. Another chemical reaction on your kitchen counter. Not all chemical reactions are spectacular. They do not always involve substances that you think of as chemicals, like the one in the lab or an acid rain. Have you ever been in the kitchen when someone chops an onion? Have you ever sliced an onion yourself? When you hold an onion in your hand, nothing happens. After you cut into it, a chemical reaction can take place. Cutting into an onion breaks apart onion cells. Those cells release substances into the air in the form of a gas. Those substances are called sulfuric acids. Sulfuric acid molecules move faster and move farther apart, so they spread out in the room. When molecules of sulfuric acid get into your eyes, they can react with the water in your eyes to produce a new substance, a form of sulfuric acid. Sulfuric acid can be very dangerous. However, in small amounts, like in an onion, sulfuric acid does not actually harm your eyes. The burning sensation is what you feel when the new substance is produced in your eyes. You may remember from studying the eye that the eye is full of nerve endings. Sulfuric acid irritates the nerve endings. Your tears are your body's way of washing away the sulfuric acid. Now you know why people cry when they cut an onion. As you think about that, what are some ways that a person might be able to avoid this chemical reaction? You might want to share what you have learned about onions with people you know who cook at your house. Next time they cook with onions, they can try to make the process less irritating to their eyes.